So I guess we will begin today by saying hello to our DECA Florida people. As you see when we start every lesson, homework's on the board. Take a second to write that down. And when we do get to, so this obviously not due tomorrow, maybe Mondays will be a stretch. We'll see if we get there. Depends what we get covered today. So the reason I stress why this section is so important is just looking at the name, I think you can probably guess that this section is relatively important. Fundamental theorem of calculus. And it's really, now that once we really get a good understanding of this section, you're really way closer to really knowing most of the material for calculus. This is a really important part moving forward. So you guys know this integral. What does it mean to you?
From 0 to x.
The area under the curve from 0 to x.
You're finding the area under the curve from 0 to x. Okay? And what I want to do now on the next slide is I want to start keeping this function the same. All right, keeping f of t the same. And so there's really like two pieces going on here. But I want to change this. I want to change the x. And I want to say, well, what if we look from 0 to 1? And what if we look from 0 to 2, 0 to 3, 0 to 4, and so on? All right, so what we are then going to do is we're really creating a separate function. So yes, there's the function that we are taking the integral of. We're finding the area under this curve f of t, but we're really looking at a completely different function. What's its behavior as I change the x value on the top? All right, so does that make sense, what we're about to be doing? All right, so here's the function, and the function f of t is actually a picture. All right, it's this red line written on the graph. F of t is the red line written on the graph. What we are going to do is we're going to find the values of g of 0, g of 1, g of 2, g of 3, g of 4, g of 5, all right, which is the values that get substituted in right here. We are going to find the area under the curve from 0 to 0. 0 to 1, from 0 to 2, 0 to 3, 0 to 4, 0 to 5. Then we'll start examining that behavior. All right, so the area under the curve from 0 to 0 should be, I hope, a straightforward answer. Yes, that was a formula from the last section. The area under the curve from A to A is always 0. So the area under a curve from 0 to 0 is 0. G of 1, sum up from 0 to 1, I want the area under the curve. So that's looking, starting at 0, ending at 1. And look, what shape do we see? A triangle that has a base of 1 and a height of 2. So overall, I heard, Elias, what's its area? The area under that curve is 1. Actually, I'm going to try to write all in red here. Okay, well, if I switch this and I try to find g of 2, the area under the curve from 0 to 2. Okay, so if I go from 0 to 2, that starts here at 0, it ends here at 2. I already know this green triangle has an area of 1. I'm really introducing what new shape? A rectangle. And that rectangle has an area of 2. So total area from 0 to 2, 3. Does everyone agree so far? All right, so at this point, we got to introduce some estimations for g of 3. So for g of 3, this is going to be an estimation. Let's see. The integral from 0 to 3 of f of t dt. So we already know this rectangle right here had an area of 2. Now I'm looking at this curved line right here. And we're going to estimate that area. Okay, because it's a curved line. There's no formula for that area of a curved line. So I would, and it's a little bit over 1. I was going to say 1.4, but Rich is saying 1.5. Do you guys have a preference?
Wait, what are we talking
We're trying to estimate how big is this area in
about?
here.
Sorry, are we saying this?
What are you saying? Estimate.
Oh,
Right?
estimate.
Estimate. Is it, I would
It looks like
agree,
it's bigger than 1.
it's definitely bigger than 1. Do we agree?
No, no, no.
We can go, I was saying 1.4, 1.5, 1.3. I think they're all good answers. What do we want to say? 1.3. Okay. 1.3 is that area. So then the total area under the curve from 0 to 3. 4.3. I'll stick with red. All right, G of 4. Now what I tried to do, I tried to make this shape from 3 to 4 exactly the same shape as 2 to 3. So I would think this area is also 1.3, but that does not mean the area under the curve is 5.6. What do I mean?
Not able to subtract.
Why do I subtract it?
Because it's underneath the x-axis.
Anytime it's underneath the x-axis, it's considered to be a negative area. So then what's the area under the curve from 0 to 4? 3. That's where we were. All right. And what do you think the area under the curve from 0 to 5 would be? It'd be 3 minus 1.3, so 1.7? So far, so good. Any questions? What I'm going to try to do is keep this red line here. I'm just going to erase this stuff because we don't need these parts anymore. What I want to do is we have a nice little g of x function, right? We have 6 coordinates that we know are approximately on g of x, right? And I want to plot them right on our axis. I will use blue for this color, so I know 0, 0 is on this axis. I know 1, 1 is on g of x. 2, 3. Let's see, what do we got here? We got 3 comma 4.3. 4 comma 3. 5 comma 1.7. All right, so if I was going to do, so if I was going to connect this, right? Now, if you were to assume that this red line right here goes up, what's going to happen to the area as you go towards g of 6? The area is going to be above the x-axis, right? So what's going to happen to g of 6? It should be increasing, right? It should be getting larger here. Okay, so now my question to you is, how is g of x, the blue line, related to f of t, the red/green line?
It almost looks like
There's some key
it
facts.
almost looks like a
Yes.
derivative.
Why would you say that?
Because the slope of the tangent line at the point for 3 is it looks like the f of t is the derivative of g.
It looks like f of t is the derivative of g of x. Does that look? Why does so keep going, Rachel. What else do you see? I think what'd you say again?
I said that the point for 3 on g of x is coordinated with
It's a
f of t
maximum,
is
right?
yes,
It's a maximum, and we know maximum's the derivative at a maximum coordinate is 0, right?
Yeah.
So that's true. All right. So left of so let's talk. Where the graph is positive, right? From 0 to 3, the derivative is, if we're hypothesizing that this is really the derivative, g of x, right? Where the derivative is positive, what's happening to g of x? Sounds like a derivative? Where the derivative is negative, what's happening to g of x? It's decreasing. And after here, and that's why I put that point in here, when the graph goes back to positive, what's happening past 5? Right? When the derivative goes back to positive, the graph shifts back. This is a huge connection in calculus. What's happening here is g of x and f of t are related. Right?
So
That is the derivative. That is 100% exactly what you were supposed to see. g of x and f of t are related. How are they related?
F of t is the derivative of g of x.
Well said. F of t is the derivative of g of x. All right. That is there's two parts to the fundamental theorem of calculus. That's part one. All right. That's what's going. So do we have
Wait,
questions on this slide?
So, just the function itself is the derivative of g of x?
And I've got it all written out on the next slide. Fundamental theorem of calculus, part one. Now the key parts to it, it doesn't have to be from 0. It can be from any value a. We looked at it at a. So if f is continuous on ab, then the function g defined by g of x. So that's what we were talking about in the last one. G of x would have meant we changed this, right? As we changed the number above at the top of the interval of some function, well, then it meant that the g of x is equal to, and I've seen it notated both ways. Sometimes they notate this f of x. Some people prefer to call this f of t because it's called f of t over here. Essentially, when you're looking at that f of t, it's the derivative of g of x. And the rest is just saying, to be able to, for this to be true, it has to be a continuous graph. F has to be continuous. So if f is continuous, then g of x is also going to be continuous. It's also going to be differentiable. And you're going to find that the derivative of g of x is just f of t or f of x, however you want to say it. And actually, Rachel, this is almost exactly what you said verbatim in the last slide. The derivative of g of x is the same as f of t, right? So it's just a switch of variables is really the key here. So the first two questions are going to look very straightforward. All right, so here we are asked to find the derivative of g of x. Right? Here's g of x. It's the same notation as we had on the previous problem, right? Well, the derivative of g of x is always located just past the interval, right? So using the fundamental theorem of calculus, part 1, g prime of x requires little to no work.
Is it the square root of 1 plus t squared?
Except instead of saying t squared, you're going to say a different variable.
Oh, excellent.
The derivative of g of x, like I said, it requires little to no work if you know the fundamental theorem of calculus. The derivative of an integral, all right, what the fundamental theorem of calculus really states, the derivative of an integral from 0 to x is just the function after the derivative. Make sense? All right. The only other part, and the only way, so this would be a very straightforward AP test question. They like to make them a little more challenging. And again, the notation, this notation, d over dx just means find the derivative of secant x to the fourth is part of your answer. So here, the derivative here, right, is going to be the secant of x to the fourth, but because x to the fourth has been substituted in and we're taking a derivative, we have to include a chain rule. So there's one extra multiplication here. What do you think we multiply by? 4x to the third. And that would be the derivative. So if you consider this function to be g of x, then this would be g prime of x.
So you substitute the b value in for t or whatever it is, and then
And if it's not x, you have to use a chain
then
rule.
you have to
That is well said.